Good day, class. The topic of today's lesson is a geometric figure that is fundamental to the study of geometry. These figures are called angles. Angles are all around us. So what we're going to do right now is take a look at a few pictures that illustrate all the different places in your life where you might see angles. Angles are used extensively in the art world and by artists to create beautiful works of art, like the one that you see here. Taking a figure as simple as an angle can turn a blank canvas into something extremely beautiful. Angles are a common sight in modern architecture. Notice all the sharp angles on this structure that give this building a distinctive look. There are a lot of different angles in there that I'm going to highlight. This photo here shows a skyscraper, the very top of the skyscraper, with a nice, well-defined angle right up here. The game of pool is built on angles in geometry, and if you're good at calculating these angles, you can become a very good pool player and maybe even win a lot of money. As this picture illustrates, many of the shots that you make in pool have very calculated and measured angles, and if you can manipulate these to your advantage, you can become a very good player. In this photo, our fearless leader, President Obama, is calculating all these angles in his head, and he's trying to make the best possible shot that he can. I could go on and on about all the different places that angles appear in your life, but let me give you guys one more real-life application that you might find interesting. The fields of photography and broadcasting use what are called camera angles. Now, this is something you do even when you take a picture of somebody. You try to get that perfect angle. You might want to just get a shot of them at eye level. Maybe you want to stand up on a chair or get a higher angle on things. Or we could have a situation such as in a sporting event where you have a blimp getting a top angle, a bird's eye view of all the action. So these angles are very critical as they create a different effect depending on how you film an object. So let's get into the geometric definition of an angle. An angle consists of two rays that share the same endpoint. So you have an endpoint here, and then you've got a ray going out that way, and you've got another ray going out that way, and the key is that they share this endpoint. These rays are the sides of the angle. Every angle has two sides. And the point where the rays intersect is called the vertex. So this would be the vertex right here. An important skill that you're going to need for geometry is how to name an angle. Now, we can name an angle in a number of different ways. One way that we can name an angle is by using its vertex. So if you look at the angle at the right, its vertex is M. So we can go ahead and call that angle M. Another way we can name the angle is by using a number if it has one. So if you look right where the two rays intersect, there's a number 1. We can also call this angle 1. Another way we can name an angle is by using all 3 points on this angle, as long as we keep that vertex in the middle. So we're going to call this angle O, M, G. And we can also name it angle G, M, O. We also need to know how to name the sides of an angle. Now, as you recall, the sides of the angles are the two rays that it consists of. So here, our two sides are going to be M, O, because you always name a ray by starting with its endpoint, and you draw the ray symbol to the right. And our other side is going to be MG, the ray going to the right. So now that you know how to name an angle as well as its sides, let's take some time to practice. I'm going to draw two different angles here, and I want you to pause the video if you have to and name the angle in as many different ways that you can, and also name the side. So here go the two angles. So I'm going to draw my two rays connected by this common endpoint. Let's get two other points out here. And this point is R, E, and D. For our second angle here, I'm going to draw my vertex. Let's make that Y. And we'll get a couple other points out here, X and Z. So again, pause the video if you have to, and what I want you to do is try to name these two angles in as many different ways as you can. Let me go ahead and add a number on this angle right here. So for the angle on the left here, you might have named this angle E, because E is a vertex. Or you might have named it angle R, E, D. And one last possibility was angle D, E, R. As far as the sides are concerned, remember every angle has two sides and they're both made out of rays. You have ray E, R, and you also have ray E, D. Let's move on to the second angle here at the right. So this one has some more choices because you have that number right in the middle there. So we could call this angle Y. We could call it angle 5. You can name it angle X, Y, Z. And also angle Z, Y, X. The sides, again, are made out of two rays. So we could name these sides as ray YX and ray YZ. Now, sometimes we get more than one angle that shares a common vertex. So let's look at this example here, and the directions state, name all angles that have A as their vertex. So there are a lot of possible answers for this question, but I'm going to try to write down some of the easiest ones. So hopefully you see three angles in there. One angle that I'm going to write down is angle 1. And I chose angle 1 because that was easier to write than angle BAD. And now we also have angle 2. A third angle that you might have noticed is this entire angle here that encompasses both angle 1 and 2. We're going to use those three letters to name that because we don't have a number that can be used for that entire angle. So I'm going to call this angle B, A, C. I wanted to mention something very important here that gives students a lot of confusion. When there's more than one angle at a given vertex, in other words, if they all share the same vertex, right here, there's a lot of angles that have the same point here, point A, we have to use 3 points to distinguish this angle, or a number. To clarify what I just said, let's imagine I decided to name this angle right here, angle A. Now, if I called that angle A, I really wouldn't know which angle you were talking about because not only does angle 1 have A as its vertex, angle 2 has A as its vertex. So when this happens, when you have that vertex that has a lot of different angles that share it, do not use a single letter to name that angle. You got to get more specific. Call that first angle angle 1, or call it angle BAD, but do not call it angle A. So we're going to wrap up our lesson on angles by distinguishing between the interior and the exterior of an angle. An angle divides a plane into 3 distinct parts. So whenever you have an angle, you can have points that are actually on the angle. They're just on this angle itself. You can have points that are on the interior of this angle, which is this yellow section here. And you can have points that are on the exterior of the angle, which would be out here, section that is in blue. So let's look at one final example. And on this example, we are going to tell whether each point is in the interior, exterior, or on the angle. And the points that we are going to focus on are these 3 down here. So let me start off by coloring the interior of this angle. So I'm going to color that inside part, which is everything between those 2 rays. And let me pick a different color out here for the exterior. So there's all this section outside of those rays. That'll be our exterior. So let's focus in on this question here, point P. So by coloring that in, it's obvious that point P, right here in that yellow section, would be on the interior. Looking at point R, which is right over here, that would be on the angle. And the last point that we want to look at, point Q, which is out here, will obviously be on the exterior.